welcome to everyone on the line. I'm very much looking forward to running our next iteration of the Security Middle East webinars. Today we've got a very interesting topic that we will be covering. Essentially, governments and security leaders of both government agencies and critical infrastructures, especially in the Middle East, are under intense pressure to firstly modernize their security environments, but also to respond to evolving threats. And we're all very aware of the perilous nature of the threat landscape in the Middle East at the moment. So senior leaders are being forced to proactively take steps to securing their enterprise, their ecosystem, and potentially using innovative technology such as edge AI and integrated systems to proactively respond to a variety of different threats. Now, as many of you will know, my name is Daniel Norman. I'm the webinar chair for the Security Middle East magazine. And this webinar today brings together two industry leaders. We have MVP Tech Convergint, the region's premier systems integrator, and Blaize, who are pioneers in edge native AI hardware and software, to showcase how centralized smart security powered by edge AI is redefining national protection. And by way of introduction, I have the pleasure of introducing Issam Shabani, who is the Director of Pre-Sales and Business Development. This is probably the fourth or fifth webinar we've done together, so welcome back, Issam. Issam has, a tremendous amount of experience in managing both commercial and technical designs of complex security systems for a wide array of clients, and demonstrated expertise in milestone setting successful deployments across the Middle East. Now, joining Issam is Dmitry Zakharchenko, the Chief Software Officer at Blaize. Now, he has a proven record in executing cloud, mobile, and AI capabilities and inventing first-to-market products and features, and brings almost 21 years of experience in strategic planning, technical commercialization, customer engagement, and developing products that solve customer problems. Now, let's introduce the webinar. Now, I've kind of set the scene in terms of highlighting, the urgency of evolving physical security strategies and digital strategies amid growing geopolitical, cyber, and physical/infrastructure threats. Now, I'd love to start with yourself, Issam. Why now? Why the shift from reactive, potentially siloed and legacy security operations to more of a unified, smart AI-enabled ecosystem? Could you potentially share how this evolving sort of approach across the Middle East in national scale projects?
Thanks, Dan, and I'm happy to share the stage with Dmitry, one of the pioneers in the industry. Look, we're lucky to be in a region where the thinking is always progressive, and the moment the technology became available for the commercial market, we were in the region the pioneers, I would say, in stepping ahead and adopting many of these concepts. If you go back to 2014, Dubai launched an initiative at the time, which is Smart Dubai. The initiative was very wide, but part of it was basically introducing AI into government services and applications. It was followed again in 2018 by Dubai Paperless Strategy, and then again launching Dubai Digital Authority in 2021. So the trajectory has always been towards modernization, towards AI, and how it can improve the way we do things and we serve the customers, the clients, and even us as users of the industry. At the same time, around the same period, Abu Dhabi launches ATRC, and ADIO invests probably north of $200 million into AI. And then again, in the beginning of 2021, from Abu Dhabi, more than 20 billion dirhams worth of investment goes into creating different AI companies and AI frameworks. Of course, this is happening in congruence with what's happening across the world in the tech capitals from which Dimitri comes from as well. So it all sort of was happening simultaneously. Now, it was only natural for the AI tech to find its way into the physical security space. So you can say in the bigger picture of things, we rode the wave initially with the vision of the leadership and the investment and money going in. PIF also in Saudi invested more than $40 billion a couple of years ago in launching the AI space. So it's all happening together, and then we're seeing the better part of it in our industry in both the hardware and the software space.
Okay, thank you very much, Issam. Yeah, it's very clear that we're operating in a region that is incredibly ambitious and prepared to take more progressive steps when it comes to securing the entire nation and nations within the Middle East. But Dimitri, I'd love to come to you here, and I'd love to touch on the element of transformation at the edge. And I'd love to get your opinion on why smart surveillance requires more than just software. How does purpose-built edge AI hardware and accelerated processing at the perimeter enable governments to act in real time?
Certainly. Thank you, Dan, and thank you, Sam. It's a pleasure to be here today. Yes, the best way to think about it is that for a number of years, the industry has been associating artificial intelligence with massive data centers where most everything's been processed in a fairly centralized fashion. Many of the examples that we've seen is that required a great amount of information traveling basically between where the sensors were in the field to that centralized location. Most of the time, for a lot of the use cases in the early days of AI, they were sufficient. If you think about it, the ratio of training versus, for example, inference is historically been anywhere between 4x to 5x training to inference, meaning that the amount of information that is processed by the sensor is 4 or 5x that much. That means that information grows exponentially, essentially every year, and ability to send that amount of information is now limited by the capacities and bandwidth available either by wireless or even by wired channels. Sensors are everywhere. There is literally millions and millions of sensors that actually continuously deliver information for processing. At the end of the day, the best systems that can actually handle it is the systems that can handle it real time, right next to the data. And a lot of the processing that's mission critical needs to be extremely low latency. Blaize's hardware has been actually designed to operate right where the data is, right next to the camera, next to any type of a sensor, including radars, lidars, whatever that happens to be that the security or law enforcement entities are using. That brings us to a system that actually is giving the governments ability to make decisions. It could be either fully autonomous or it could be recommending a decision. But at the end of the day, the most important thing that it's low power, but low latency as well. And it's actually acting in real time. Most of the systems that we've seen up to this point indicating that even delay over a couple of seconds for example, in a traffic situation could lead to some really significant consequences that every government is trying to avoid. So that's what Blaize been essentially demonstrating, ability to make decisions real time.
Okay, thank you. So thank you both for setting the scene about the challenge that governments and critical infrastructure are facing. I'd love to move on to topic one, which is from silos to synchronization, centralized smart security. And I'd love to come back to yourself, Issam, and focus on maybe the first question, which is what are the core design principles behind a centralized smart security ecosystem that remains agile across ministries and infrastructure silos?
Well, a heavy question, and I'm gonna try to compress my answer as much as possible. But I really invite whoever sees the webinar or attends it, if they have further questions or they like more information about, you know, what we think of it or our answers, please reach out to us after the webinar. So, I mean, there are a few things that we look at seriously when it comes to the let's say the principles side of the design. When we build these systems, we want the systems to be ready for the kind of operation we're looking at. So the first element we look at is, we call it federation. So when you have most of these government facilities are not only one site, they're multiple sites, and most of them have the vision that I want to do a lot of AI on the edge, a lot of surveillance and all of these things, and I want to be able to push things back to a central command and control. So when we design, we look at federation as one of the key design factors. The systems has to be ready to incorporate federation. Another thing, and I'll leave it to Dimitri, I'm sure he spoke about it, he'll talk more about it, but AI-driven situational awareness, which gives you the speed and the effectiveness to look at data in real time and make decisions live. Another aspect is the open platform. We talk about this so much, but when we select the elements of the centralized security system and the whole security system, we focus on open platform, real open platform, software and hardware. There's another thing, which is scalability. Many of these installations are designed a bit small in the beginning, and they tend to grow and become more complex. We want the systems that we propose to be always capable of going along with the scalability that's expected. You might start with 10, 20 devices and a few features on the edge and end up with multi-thousands. Maybe the last element I'll talk about is related to the geospatial viewing of these systems. So a lot of the solutions that are related to this level that we're talking about, which is enterprise and government, are incorporating more and more visual element to their systems. So they want to see maps. They want to see the AI data overlaid on maps. They want to manage their operation on live and dynamic maps. So it's all getting shaped together eventually to have the capability to go big and effective on these solutions.
Thank you, Issam. And in your recent regional projects that you've been involved with, what have been the real impact drivers of centralized AI-based systems, from operational control to better resilience?
So I can talk about maybe 3 different use cases that we have seen. One of our big customers is a large utilities provider in the country in UAE, and they look after critical infrastructure. So the impact for them in deploying a certain level of AI at the edge is the fact that they managed to discover a lot of theft that's happening that was not even that they were not even aware of. It's simply because the systems are capable of detecting anomalies that are happening, and from investigating the anomalies, we managed to pick up a lot of theft that's happening in those facilities. Another aspect is the safety. Of course, you can rely on security guards so much, but when there's a lot of let's say sabotaging that might be happening, or people try to steal basic things like cables and other stuff. So instead of waiting for people to put themselves in the face of harm and get electrocuted or anything like that, you pick up these incidents effectively and can deal with them fairly quickly. Another customer, which is a policing customer for us also in UAE, big customer. The AI application on the security system helped them basically in issuing more fines more effectively day and night to people for violations. And you know it then. I mean, when you get a fine for a seatbelt at a certain time, next time you take the same road or you even get in the car, you're gonna remember to put on the seatbelt. So it had an impact on the revenues, more revenues, and it had impact on public safety. And it helped people, I mean, push people to commit to rules. Last case I would say is we do serve a lot of tech giants from around the world. Many of them literally have hundreds of facilities spread all around the globe. Imagine like in the world before, when you were receiving the data too late about what's happening and not very accurate, versus now when you are able to get exactly the efficiency on loading bay number 8 in Jeddah, for example. You get this type of data live to your headquarters in US or Europe or China. Imagine the efficiency of you making decisions and the amount of data coming from all around the world, and then it becomes basically a gold mine of extracting valuable information that helps you in decision making.
Thank you, Sam. I'd love to come to yourself, Dimitri, here and follow up with some of the questions here, which the first one I have is how can edge native AI reduce cloud dependency in high stakes environments while preserving latency, security, and compliance requirements?
Certainly. Thank you, Dan. I think a lot of the examples that Issam was mentioning, they're all about being where the data is and what's happening with the data when it is in transit. The industry has been dealing with a lot of the security-related paradigms over the past 30, 40 years, especially in the cyberspace. But what's really happening now with the introduction of new AI paradigm is that being able to work with the data, where you actually convert the data into knowledge, right, by the source of it, let's say, again, by the camera, by any type of a sensor. What happens is that it significantly reduces basically the surface of attack. When you think about it, is that when the data could be treated as a vector of attack, because of the sheer size of the data that's being transferred, it actually makes it very easy to hide whatever you're basically trying to hide. But when you send knowledge instead of data, you're really sending kilobytes instead of gigabytes. It makes it a lot easier for anybody whose job is to make sure that that information is basically clean from any malicious code. It makes it exponentially easier. So gigabytes versus kilobytes. And it's not just fast and lean, it's also safer. And it's also keeps kind of the risks right by that individual node rather than inside the centralized system.
And what roles do you think purpose-built silicon play in enabling fast, accurate insights within centralized security operations?
Absolutely. Well, we spoke about the low latency and the need to be real time. This is certainly stays, but it's also interesting to think in the context of the security that traditional, for example, traditional GPU-based systems, they're designed to execute pretty much any code. I mean, when you think about it, the GPUs are essentially been designed to be gaming accelerators, but they can run whatever code the actor decides to put on it. It's not very difficult for us to see that the general purpose processors can be used even for the ill intent. And in contrast, when we think about it, purpose-built silicon, for example, like the one from Blaize, it's actually been from ground up designed to run AI workloads only. And it does contain the necessary pre-processing and post-processing technologies, but at the end of the day, it's a very lean, highly optimized code that this processor is actually running. So in this case, auditing is very easy. It's because of how lean the code is. They're also a lot more resilient when we think about it. Ability to handle temperatures, ability to handle, for example, poor ventilation in a lot of the scenarios. That actually relates these processors to be much more secure from the physical standpoint. You can put it in a battery cabinet, you can lock it away, you can put it on a mast. You can actually physically separate this device much better, especially in the environments where there is no security guard standing next to that. So that's the way to think about this silicon. Is both fast, but it's also a lot easier to secure.
Yeah, absolutely. Thank you for that. Now, I believe we've got a poll for the audience, and I'd love to get the answers from everyone on the line. So, poll number one is, what is your biggest challenge in building a truly centralized and responsive smart security ecosystem? So, please pick one of the options here, from lack of real-time AI, siloed systems across different agencies and ministries, limited access to purpose-built hardware, or difficulty integrating cloud and edge infrastructure. So we'll give you maybe 20, 30 seconds to go through that and choose, and then we'll review the answers immediately afterwards. Okay, we can see some of the answers flooding through. Give it another 10 seconds or so, and then we'll go to the answers. Okay, we could move on. So quite a mix, really. I think that really demonstrates that, there are a variety of challenges really that have to be overcome in order to potentially centralize the security ecosystem, as we ask in the question here. So thank you very much to everyone for your answers there. Now, look, conscious of the time, let's move on to topic two, which is covering AI at the edge, delivering real-time surveillance without compromise. And for this section, I'd love to stay with yourself, Dimitri, for question number one, which is, what are the real-world technical and operational benefits of deploying edge-native AI in latency-critical sites, such as transport hubs, border zones, and energy plants?
Yes, thank you, Dan. Well, as discussed before, I think edge native systems and solutions more and more are becoming physically and logically separated in order to maintain autonomy and speed. That really means that the requirements for efficient compute comes with the price of being extremely dense when it comes to the ability to physically package it. And in order for these devices to be both space saving as well as energy saving, we need to be thinking about what does it mean for these devices to be present in every traffic light pole, present in every security hub. Anything that the cities or law enforcement or even militaries are putting out there is continuously asking, can we reduce the power envelope? Can we reduce the power requirements? And while maintaining a very high throughput and extremely low latency. Because the decisions are being made in the real world everywhere, every second. And what we've seen in the past with the centralized systems, they function, but they don't function fast enough. When you think about what's happening with a lot of the autonomous devices or vehicles, is indicative of the fact that this decision-making needs to be pretty much synchronized with across all devices, not just an individual device that being a smart vehicle. It needs to be the smart infrastructure, vehicle to vehicle, vehicle to infrastructure, vehicle to the humans, the infrastructure to the humans. The network is so complex and so convoluted that it becomes essentially critical to have this small but efficient devices present almost everywhere that there is any level of connectivity present. And that's why in the mission critical applications like transportation, the failure of a single node should not mean the failure of the system. And that's the main thing that our chip's been demonstrating, is that our solutions are designed to run. When one node goes out, the rest of the nodes continue to function as designed. That's because there is more devices available, and there is always inherent redundancy that we build with this type of a system when it's being put in place in the mission-critical infrastructure.
Okay. And I know whenever we do these webinars, the audience love to see or hear about use cases. So, Dimitri, would you be able to maybe walk us through a use case where Edge AI analytics detected a pattern or anomaly missed by traditional surveillance systems?
Certainly. I'll just say that in one of the defense opportunities, it was very interesting. It was, let's just say, transportation related infrastructure. And the cameras were older legacy cameras that actually contained cameras with aging optics. They were continuously running into issues of the flares, some natural fogging of the lenses. And the result of that was that, for example, I'll just use this, that AI system was actually got to the point when the footage of those cameras were running, AI was actually mistaking motorcycles for the vehicles. It was missing pedestrians or humans, let's just say, in the path. So that means that the system was dealing with a very much the problem of the physical space. What we've done, we run algorithms that our systems and our processors are able to do. For example, to defog, to improve the contrast, to deflare, to denoise. And once those algorithms run, we were actually able to run the actual detecting algorithms. What we've noticed is that it significantly improved the accuracy, because with the digital improvements of the physical images that were coming off the cameras, the actual accuracy of AI detections went up by as much as 22%. So that's very significant when you think about it. If we try to do something like that in a centralized system, the round trip for this amount of data would be taking minutes instead of seconds. So this is no longer a decision system. And by being able to actually do all this pre-processing and post-processing right there by where each camera is, we were able to actually continue to use the legacy system. We just effectively digitally upgraded this network to be basically in line with the modern times, so to speak.
Okay, thank you. And I'd love to move over to yourself, Issam, here with a question in this topic, which is how do you overcome the integration and legacy compatibility barriers when deploying real-time AI analytics across very complex government-owned infrastructure?
I mean, in real life scenarios, it's a bit different than what we would like to have as designers. As designer, you'd like to go in and design everything perfect from day one, but unfortunately, this is never the case. We always have to deal with challenges of inheriting some of the legacy systems that are there. And some of these challenges include, I mean, legacy cameras, as Dimitri mentioned, with a bad quality, or you might have inconsistencies on the network itself. The method of communication between the edge site or the edge building, or whatever faraway facility, and your central command and control has some sort of issue. So we always have to deal with this with these situations. The way we overcome it is during the study phase, we try to eliminate as much as possible the type of problems that are a showstopper. So if you have a camera that's getting you video that's really beyond any repair, we try to replace it from the beginning. This is one thing that we do. And when we do the replacement, or when we suggest the replacement to that, We make sure that the products that we are bringing in are, again, open platform and AI capable, and they give you some of the capabilities that can enable a system like Blaize, for example, to do the magic that they do on them. This is one element. The second thing we focus on is whatever we are doing on the edge when it comes to AI applications, analysis, and all of these things. It's very economic in the information it's pushing through the network. Most of these networks that are in place usually do not have the bandwidth that allows you to push full-fledged video to a central location. So you always want to go economic on that. But of course, you don't want to lose the effectiveness of the data that you're taking. So the kilobytes that Dimitri was talking about of data being pushed has to be accurate and effective when you push it from the edge to the core. So this is just a sort of a teaser on these things. And then when you go back to the central location where you are receiving all of this nice data, in many cases, you end up having legacy software that are not updated to the modern capability. They are incapable of providing you good situational awareness. We try as much as possible to either to replace them or to update them to a later version that is capable of doing that. Because look, at the end of the day, the reason why governments invest in this solution is to get an operational value from it. They want to solve a problem. So the bare minimum is to be able to get good quality data that is economical from the edge, push it through OK network to a central location in the fast manner that's expected, with lowest latency possible, and at the end of the cycle, be able to use that data to make informed decisions or take actions.
Okay. And just following on from that, Issam, what are the most important lessons that you've learned when scaling edge intelligence across remote resource constrained environments?
I mean, when we look at scaling, we do a lot of studying on again, we go back to the networks subject. Like whatever you have, let it be a fiber network in place or a microwave network in place or whatever it is. We have to make sure that before we start, going full-fledged on AI analytics and scaling and all of these things, that the network has the bare minimum. Because if it doesn't, there's no point in doing any of this if you don't have the right medium to communicate what's happening on the edge. We've seen this happen in a few cases where it was an afterthought and it becomes a showstopper down the line for a project. The other aspect is we try to build more intelligence on the edge that is native. So Dimitri spoke about having a native technology on your processor sitting at the edge and doing what you're expecting it to do. The lesson learned is this is a part that as a customer or as a designer, we don't want to go cheap on, because if you go cheap or if you try to cut corners and retrofit some sort of patch engineering solution, you end up missing the whole point. You might have the best network, you might have the best command and control center, but if from the edge you are not pushing the right alerts and the right data back to a central location, then you're missing the whole point. And the last aspect maybe to talk about, assuming that you get your edge correctly and your network correctly, when we go to the central command and control, we usually work with partners like Blaize and with the end users to identify what exactly they are trying to achieve from having this AI on the edge. And the good thing about Blaize is at the end of the day, you can custom tailor a lot of these solutions and optimize it on their hardware. So we learned the lesson, maybe in some cases, the hard way, I would say, in getting parts of this cycle correctly, but not getting the whole cycle correctly. And we have, of course, learned a lot through the years, and we've been fortunate to have partners like Blaize and some good customers that went through the journey with us to where we are today.
Absolutely. Thank you, Issam. And just building on from that, I'd love to go to the next poll, which follows on from some of your sentiments in the second topic that we've covered. Now, the poll, I believe, should be coming up on screen very soon. There we go. So the poll is, what is your biggest barrier to adopting edge AI for real-time surveillance in critical environments? And the options are, which you can choose. One is legacy system compatibility, poor remote infrastructure, data privacy and compliance concerns, and scaling and maintenance complexity. So we'll give you again about 20-30 seconds to choose one, and then we'll review the answers after that time as well. Okay, we can see some answers coming in, so thank you very much for joining in. Perhaps 10 more seconds, and then we'll go to the review. Perfect. Okay. Well, look again. There's a winner, I would say, in terms of legacy system compatibility. But as with the last question, there is a real spread of answers. Again, the barriers, the challenges that we've discussed are certainly pieces that Dimitri and Issam can help you overcome. Now, moving on to the final topic, which is future-proofing national security, scaling AI-driven security ecosystems. And Issam, let's stick with you for the first question, which is mainly around the architecture. So, how do you architect security platforms that evolve with emerging AI models, threat vectors, and compliance frameworks?
Well, I I'm not sure how to answer this in a couple of minutes, but I'll give it a try. So look, I mean, the barrier between physical and cybersecurity is sort of narrowing a little bit, and the governance bodies on the cyber side and the physical side are sort of joining efforts to make sure that, you know, they set the framework on how you design these systems in a safe and secure way, an effective way. So what we usually do is we use a top-down approach, from a design perspective. So we look at a top-down approach, meaning we work with the customers to understand what do we have now, where we are today, and where do we want to get to on the short, medium, and long term, so 4 to 5 years ahead. And usually when we do this, we have the end in mind, right? So we want to understand what do you want to do today? What do you want to achieve today? And potentially how vast the system is going to expand and what more features you want and what kind of problems you might have in the future. This process allows you to design the tech required to achieve it. Another consideration, I would say, in the architecture is we're seeing that many of our customers, especially on the government side of things, they're focusing they want all of the AI and they want all of the nice bells and whistles, but they want to host it locally in their countries because they're worried about the data going somewhere else. And this is understandable. So many of our partners, similar to Blaize, they allow you to build on-prem solutions that are sometimes on-prem and sometimes hybrid solutions. So some of it on a prem and some of it is on a local or regional cloud. This is very important. And one more thing is the scalability, of course, goes without saying when you're working on projects like this. And the last one is related to the quality of the products that we put inside these solutions. So as a system architect, when I work with a hardware and a software, mainly a software provider in this sense, I want to make sure that they are continuously investing in making sure their product is, from a cybersecurity perspective, is also developing along with the threats that are developing in the market. So they pay attention to the cybersecurity aspect. We also have to make sure that it's continuously being upgraded along with the hardware that's being upgraded on the edge. This means that they are investing. This means that we will need as end users to also go along and do what we have to do on an annual basis to make sure we are updating the software and continuously doing it. Unfortunately, many of the products being sold in the market comes with so many freebies that will look as a good deal for now, but it harbors a lot of cybersecurity threats and issues that you won't see it now, but you will see it down the line when you start using the system and during operation.
Thank you, Issam. And just building on that, you talk about like, the future, and I'd love to get your perspectives on trends that you see, both in regional governance that are influencing how national and critical infrastructure security systems are designed. What are your thoughts on that?
Look, I mean, we're seeing lots of common trends, I would say, speaking about the GCC, between the GCC countries. I already mentioned a part of it when it comes to the cybersecurity aspect. You have governing bodies that are working day and night to make sure that the regulation is protecting the ministries and agencies and clients properly. This is a major trend, so heavy regulation on this side. The other trend is most of the clients, especially in the government sector, are going for interoperability in the systems. And the fact that something like Blaize, for example, is collecting this kind of data and analytics using their optimized hardware from the edge. But I would see something in this data, you, Dan, might see something else, and somebody working a different stakeholder might see something completely different. So we want to make sure that the trend is that they are taking this information and they want to distribute it to different agencies and stakeholders so that everybody can benefit from the raw data that's being extracted. This is another trend. A third thing we're seeing, I would say, more recent is the fact that many of the agencies are seeing the value in having maintenance contracts running along with these systems, because these are not type of buy and forget solutions. You need to keep modifying them, developing them, updating them on a continuous basis. That's not an easy process, and luckily many customers are realizing this early on. So we're seeing a massive increase in maintenance contracts in that sense.
Thank you, Issam. And I've got a couple of questions left from my side for Dimitri before we go to closing remarks and the Q&A. And I'm very conscious we've got a lot of questions that are flooding in from the audience, so we better save some time at the end to cover those. But finally, to yourself, Dimitri, how does your hardware and software co-design approach support public sector clients managing sensitive data and strict localization requirements?
I think there is a very good connection to what Issam was saying about the need to keep the data local, keep the data protected or within the boundaries of the specific government of the country. That leads us to maybe touch on a topic of AI has been really designed to run, like we discussed already, in the big data centers. But there is an extreme end of the AI spectrum where either defense or law enforcement or government actually prefers to have AI completely disconnected from the network for security and data protection and privacy purposes. Sometimes it's called air gap environment. It means that the system needs to continue to perform and function when it's completely disconnected from any kind of a network. But that presents a challenge in itself. When you think about it, now you actually need to be able to operate the system. And operating the system even 5 years ago really meant that you really have to sit down and write the code at the command line. And I'm sure that MVP has seen this again and again, where it's lines and lines of code every time you want to make a minor change. And of course, the talent that the MVP has is there, but being able to empower their end user to do a lot of those changes without actually writing the code is where I think there is an opportunity for the governments to improve that. Take again this air gap scenario. If you can operate the system using the same familiar interfaces that we're used to with any PC or any device that we use daily, we don't think about writing code. Most of the time we just use a very nice UI UX, and we applied the same logic when we were designing the solution. You need to be able to operate these air-gapped environments, for example, in the same way that you're operating your PCs or operating your servers, meaning that you don't write the code. You just use the familiar UX that, for example, in this case, Blaize provides. And this code is completely customizable and available. MVP can feed that code to the purposes and needs so that the users are essentially clicking instead of writing. This type of paradigm shift is what will drive ultimately the adoption of the AI. And I think the government's already seeing that. Certainly a lot of what used to be, for example, specialist domain subject matter experts in a certain industry, they are actually now able to sit down at that system and perform the necessary tasks by managing this AI system. And they don't have to go to school for several months or years to study Python and study C++ or study any of those programming languages. It's ready to go, so to speak.
Okay, fantastic. And finally, I'd love for you to perhaps summarize your answer to this question, which is, what does the future of edge AI look like, in your opinion, especially when it comes to national defense, utilities, smart infrastructure? And what are you seeing in terms of government planning around edge AI today?
Certainly. I think the days of the brute force AI, where basically everybody was just throwing more cores at the problem, I don't think it's no longer sufficient, because as we know, the operational costs and capital costs been growing, and I'm sure everybody can relate to that. I think the future is all about pragmatic applications of AI, where you can actually deliver the measurable results, measurable return on the investment. Ability to do that so that the real-time decision-making capabilities are preserved, especially in the defense and public areas, is all about building the trust between the systems and the end users. And that usually comes from the fact that those non-technical users need to be able to audit decision systems. They need to be able to reuse the code. It's actually all about building the AI that humans can actually inherently trust. And we also seen a lot of the situations where we spoke quite a bit about edge. We spoke about the separation of the edge and the data center. I'd like to maybe bring us all back in a sense that we should be writing the code once and use it everywhere as much as possible. And the interface that we build that manage the edge system, the same interfaces should be applicable to the systems that are residing either in the data center, in the field, or somewhere in between, sometimes called fog. But at the end of the day, ability to write the code once and use it everywhere is what really going to make AI scalable and a lot less expensive for the governments and for the public to implement. And I think that will significantly grow the business with the help of the integrators like MVP. That would be a brand new paradigm. The ability to deliver projects will be, the time required to deliver the projects will be reduced significantly, sometimes by the factor of several X.
Sure. Thank you. Thank you very much for your answers both. Now, I'm conscious of time. We've got about 10 minutes left, and there are a number of questions that have come in from the audience that I'd like to pose to you. Let me just flick through and find the first one here. Right. So, just building on your final comments there, Dimitri, around the future of potentially government spending and projects in the region and the future of edge AI. One audience member asks, and I'll read this out verbatim. It says, with the Middle Eastern AI and data center projects being invested in, and going on progressively in UAE and Saudi Arabia. How are these going to be scaled up moving forward with anticipated emerging quantum computing, blockchain, etc., that could significantly alter the AI and data center landscapes, including cybersecurity? Any thoughts from you two on that question?
I think it's an excellent question, and it may require a thoughtful, thorough answer, but I'll try to maybe summarize. I believe that the ability for the data to be protected, the best way to think about it, this capability is already being built. I know blockchain's been mentioned. This is actually an excellent example of how the data could be securely stored and distributed on a blockchain instead of actually most of the time traveling through the existing mechanisms that have been implemented probably 20, 30 years ago. The blockchain will also make ability for the companies to do, for example, data exchanges. But the really interesting piece, in my opinion, I wanna bring up for just a second and to open everybody's thoughts on that topic is that being able to do inference on the encrypted data without decrypting the data is where the future is. And I think with the emergence of technologies like blockchain and homomorphic encryption, we should be able to achieve that. We should be able to suddenly do insights on the data without actually seeing the data, so to speak. That will completely change the landscape, because now the companies will no longer be afraid to share their data. Instead, they will be sharing the data in order to create more insights. But there is no risk to the privacy or data protection inside that blockchain encrypted storage. So that's just something to think about. And this technology is already here. And our processors are effectively already been demonstrating ability to do the inference on the encrypted data. So the future is here, and the future is much brighter than we think it will be. A lot of the press talks about how the data becomes a new oil. To me, it's actually a new mechanism to build a better AI.
Okay, thank you, Dimitri. And any thoughts from yourself, Issam, on the future of technological investment in the region and how that may impact the topic we've discussed today?
We just heard it from Dimitri, who's at the front line of tech and this particular subject. So I'll leave it at his answer, and maybe we can take other questions as well.
Wonderful. Right, so I've got a couple of, I would say, more technical questions that I'd like to pose to you. The first one is, if an AI application fails, what actually happens? How do you design for that in critical environments?
Address to
I mean, it's either of you. I appreciate you'll probably have both maybe different technical or more operational perspectives on that. So I'll go to you, Issam. What are your thoughts?
So I mean, I'm not sure how deep we want to go on this, but we've seen cases that were surprisingly successful in AI deployments, and we have seen cases that are having some inconsistencies and issues. We have to identify what exactly happened so that your AI application is not working the way it's supposed to be. Most of these systems are using certain pattern recognition codes that are picking up certain anomalies in an event or certain patterns in an incident. It could be a breakdown on the source of the data, the camera itself. Could be a breakdown on the sensor and the processing. Most of the challenges that we have seen from our perspective is something that Blaize is solving for us nowadays, which is the processing side of things. Most of the times there's a mismatch between what you're trying to achieve and the application that you have and how the processing is actually doing the processing of the data and the video. And that's where you end up with a result that doesn't look like anything that you expected when you started putting it together. So this is something that Blaize has been solving for us. We recently had a case where we worked with Blaize on a certain application where you have products in the market that different products that are basically doing specific parts of the analytics, and using Blaize AI Studio, we managed to basically achieve what the client is expecting by using the AI Studio of Blaize, developing all of the analytics needed to achieve that particular use case. And it was a success. So again, a general answer on this subject, but we really have to know what is the source of the problem, why this AI or analytics had failed initially.
Okay, thank you. And a follow-on question there is, a lot of audience members are probably watching this and thinking, we've got legacy infrastructure and might be concerned about, how do we add AI to our ecosystem, potentially on top of legacy infrastructure without replacing everything or having a super expensive overhaul. Dimitri, do you have any thoughts on what's the smartest way to add AI to legacy infrastructure within an organization?
Well, I think so. One of the things that I think we're starting to see more and more happening is that ability to collocate, for example, smaller AI systems, AI decision systems together with an existing infrastructure requires a solution that's fully packed, meaning that think about a rack that contains everything that you need, the software, the hardware, the actual physical components, all fully enclosed in a small rack or half a rack. You locate that in the existing, within the boundaries of your firewall, you turn it on, and instead of going through a complete process of transforming your entire infrastructure, entire software ecosystem, you're just essentially adding it in. And that's the way that we've been approaching. That's the work that we're doing with MVP, is to make sure that this is becoming a fully packaged solution rather than bits and pieces that the infrastructure owners have to assemble themselves. Bring it all together, package it, make it readily available, not just on the edge, but also in the data centers. This is very important. The same software and the same hardware that we've been discussing for the edge is actually could be packaged into very dense solutions that they can add into their infrastructure inside their data centers, inside their firewalls.
Brilliant. Thank you, Dimitri. Now, I'm again conscious of time, but I mean, we could probably talk about this topic for hours. So I would certainly recommend any of the audience members to explore both of MVP Tech's and Blaize's websites. Definitely have a look at the QR code here to explore some of the content they have. But massive thank you to both Dimitri and Issam for your perspectives. Huge thank you again to the audience for being involved and for your questions. And look, if you have any questions, I know that the team online today will be happy to answer them. So thank you very much. And Issam, Dimitri, any closing words from yourselves?
Well, no, nothing from my end. Thank you, Dan. Thank you, Dimitri. Was happy to share the stage with you guys. And please invite anyone who attended or will see this later to reach out. These are very heavy topics. And like you said, we can talk for hours about them. We'll be happy to help.
Massive thank you for giving a chance to be a part of this distinguished panel. Thank you.
Thank you very much. Thanks to the audience, and we hope to see you all very soon.